Imagine pouring billions of tons of salt water onto a volcano. Sounds crazy, right? But sometimes the most unconventional ideas can lead to groundbreaking discoveries. This isn't just a wild thought experiment, it's a real-life scenario that scientists embarked upon with a clear objective in mind. In a daring and unprecedented operation, scientists decided to take on the challenge. They weren't just playing around, they had a well-thought-out plan, and a team of experts working tirelessly to make it happen. This wasn't some strange science experiment gone wrong, it was a calculated risk backed by years of research and data. The scientists knew exactly what they were doing and why it was necessary. They had a good reason to try to prevent a dangerous volcanic eruption. The stakes were incredibly high and the potential consequences of inaction were dire. Volcanoes are powerful forces of nature. They have the ability to reshape landscapes, alter climates, and impact entire ecosystems. Their eruptions can be both awe-inspiring and terrifying. When a volcano erupts, it can spew fiery lava and deadly gases, posing a significant threat to nearby communities and the environment. The devastation can be widespread and long-lasting. Scientists are always looking for ways to predict and manage these eruptions to protect people and the environment. Their goal is to minimize the impact and save lives. This incredible experiment, pouring salt water onto a volcano, was a radical new approach to managing volcanic hazards. It was a bold move that required careful planning and precise execution. The chosen volcano was showing signs of unrest, with increasing tremors and gas emissions. These were clear indicators that an eruption could be imminent. The hope was that by pouring salt water onto it, they could cool down the volcano and reduce the pressure building up inside. This would potentially prevent a catastrophic eruption. It was a risky plan, but the potential rewards were huge. If successful, this method could revolutionize how we manage volcanic threats and protect vulnerable populations around the world. But why saltwater? What's so special about it? The science behind this operation lies in the properties of saltwater. Firstly, seawater is much denser than freshwater. This means it can seep deeper into the Earth's crust. Secondly, saltwater has a higher boiling point than freshwater. This means it can absorb more heat before turning into steam. By pumping salt water into the volcano, scientists hope to achieve two things. First, the denser salt water would penetrate deep into the volcano, interacting with the hot rocks and magma. Second, the salt water would absorb a significant amount of heat, cooling down the volcano's core. This cooling effect could potentially prevent the buildup of pressure that leads to eruptions. Getting billions of tons of salt water onto a volcano is no easy task. It was a massive logistical challenge. First, they had to find a reliable source of salt water. The ocean was the obvious choice, but it was still miles away from the volcano. A complex network of pipelines and pumps was built to transport the seawater. These pipelines had to withstand the corrosive nature of salt water and the challenging terrain. They stretched for miles, carrying the ocean water up the slopes of the volcano. Imagine the amount of planning and engineering that went into this project. Building this saltwater delivery system was a feat of engineering in itself. The operation to pour saltwater onto the volcano lasted for an incredible 160 days. This wasn't just a simple task, it was a monumental effort that required meticulous planning and execution. Imagine the logistics involved in continuously transporting and pumping salt water for such an extended period. The sheer scale of this operation was mind-boggling. Day and night, the pumps worked tirelessly, delivering a constant flow of seawater. These pumps were the heart of the operation, ensuring that the volcano received a steady supply of salt water. The engineers had to make sure that the pumps were always in perfect working condition, as any malfunction could jeopardize the entire mission. It was like a giant tap left running, but instead of water flowing into a bathtub, it was being poured into a volcano. The visual of this massive tap is a testament to the scale of the operation. The continuous flow of water was crucial in managing the volcanic activity and preventing potential eruptions. A team of scientists and engineers worked around the clock, monitoring the volcano's activity and adjusting the flow of salt water. Their vigilance was key to the success of the operation. They had to be constantly on alert, ready to make real-time decisions based on the data they were receiving. They used sophisticated instruments to track the temperature, pressure, and seismic activity within the volcano. These instruments provided critical data that helped the team understand the volcano's behavior. The data collected was analyzed meticulously to predict any changes in the volcano's activity. They were like doctors in an operating room, constantly checking the volcano's vital signs. Just as doctors monitor a patient's health, these scientists monitored the volcano's condition, ensuring that it remained stable and under control. It was a tense and demanding job, as they had to be ready to respond to any changes in the volcano's behavior. The pressure was immense, knowing that any misstep could have catastrophic consequences. Their dedication and expertise were the backbone of this extraordinary operation. Pouring billions of tons of salt water onto a volcano raises some important environmental questions. Would it harm the surrounding ecosystem? What happens to all that salt? These were serious concerns that scientists had to address before and during the operation. One concern was the impact of salt water on the volcano's delicate ecosystem. Volcanic environments are often home to unique and fragile plant and animal life that has adapted to the harsh conditions. Scientists carefully studied the potential risks and implemented measures to minimize damage. They monitored the surrounding environment closely throughout the operation, looking for any signs of negative effects. As with any large-scale experiment, there were some unexpected consequences. While scientists had anticipated some changes in the volcano's behavior, nature had a few surprises in store for them. One of the most noticeable effects was the appearance of strange mineral formations around the volcano's vents. The salt water, reacting with the volcanic gases and minerals, created a colorful array of crystal formations. It was like the volcano had sprouted a salty, crystalline beard. These unexpected formations provided valuable insights into the chemical reactions happening deep beneath the surface. Another unexpected consequence was the impact on local wildlife. Some animals, like birds, were initially driven away by the increased activity around the volcano. Measuring the success of the salty solution. After 160 days of pouring salt water onto the volcano, the big question remained: did it work? The process was long and arduous, involving meticulous planning and execution. Each day, scientists would pour a measured amount of salt water onto the volcano, hoping to see a change. The anticipation grew with each passing day, as the team eagerly awaited the results of their groundbreaking experiment. The operation was carefully monitored, and the data collected over those months provided valuable insights. Scientists used advanced equipment to track every minute change in the volcano's behavior. They recorded temperature fluctuations, pressure variations, and even the chemical composition of the gases emitted. This comprehensive data collection was crucial in understanding the impact of the salt water on the volcanic activity. Scientists observed a significant decrease in the volcano's temperature and pressure. The graph showed a steady decline, indicating that the salt water was effectively cooling the volcano's core. This was a promising sign, as it suggested that the risk of an eruption was being mitigated. The team was cautiously optimistic, knowing that they were witnessing something unprecedented. The salt water had successfully cooled down the volcano's core, reducing the risk of an imminent eruption. The steam that once billowed from the crater began to dissipate, and the once fiery glow of the lava dimmed. It was a remarkable transformation, one that brought a sense of relief to the scientists who had dedicated so much time and effort to this project. It was a major achievement, and a testament to the innovative thinking of the scientists involved. Their hard work and determination had paid off, and they celebrated this milestone with high fives and cheers. This success was not just a win for the team, but for the entire scientific community, showcasing the power of creative problem-solving. However, it's important to note that this was a temporary solution. The sign next to the volcano served as a reminder that while the immediate danger had been averted, the underlying issue remained. The volcano was still active, and the saltwater treatment was not a permanent fix. The volcano was still active and the risk of future eruptions remained. Smoke continued to rise from the crater, a stark reminder of the volatile nature of the beast. The team knew that they had only bought themselves some time and that continuous monitoring and further research were essential. The operation bought valuable time and provided a unique opportunity to study the volcano's behavior in a controlled environment. This controlled setting allowed scientists to gather more precise data and refine their methods. The knowledge gained from this experiment would be invaluable for future volcanic activity mitigation efforts, potentially saving countless lives and preventing widespread destruction. The operation to pour salt water onto the volcano was an ambitious and audacious experiment. While it was successful in temporarily mitigating the risk of a volcanic eruption, it also provided valuable lessons for future volcano management strategies. One of the key takeaways was the importance of understanding the specific characteristics of each volcano. What works for one volcano may not necessarily work for another. The experiment highlighted the need for tailored approaches to volcano management, taking into account the unique geological and environmental factors of each site. This experiment pushed the boundaries of our understanding of volcanoes and paved the way for more innovative solutions in the future. The success of the saltwater operation has opened up new possibilities for volcano management. While it may not be a permanent solution for every volcano, it has proven to be an effective tool in certain situations. Scientists are now exploring the potential of using saltwater to manage volcanic activity in other parts of the world. They are also investigating other innovative techniques such as drilling deep wells to release pressure from magma chambers. The lessons learned from this experiment will undoubtedly shape the future of volcano management. As technology advances and our understanding of volcanoes grows, we can hope for a future where we can live in greater harmony with these powerful forces of nature.